Welcome in the second part of argparse tutorial. Today, as I said in the first video, we'll build a network scanner, and to do that, we'll use, of course, argparse module. So we will use argparse to build our command line interface, and we will use as well Scapy module. It's an external library that will allow us to craft packets that will be then used to discover hosts on the local Ethernet network. So I have it pre-installed already, but I will put a link to the documentation if you want to follow along with this video. So without further ado, let's get down to it. I'm here in my Spider IDE, and first of all, I'm gonna import argparse module, and we'll create few functions to build our network scanner, and we will then implement them into one main function. And in the main function, we'll have the main logic as well for our utility. All right, so the first function will be based on argparse, and it will allow us to parse the arguments that we will provide, or a user will provide, on the command line. So I'm gonna call it getArgs, and this will not take any arguments, so we are not defining any parameters here. And first of all, as you remember, we need to create a parser object. So from argparse module, we're gonna take argument parser class, and we're gonna, right at the beginning, we're gonna fill in a few keyword arguments. And the first one is the name of our program, and this is the proc keyword argument. And we're gonna call it network scanner. The second keyword argument is description, and we're gonna say network scanner based on ARP protocol. So our utility will send ARP requests, ARP pings, to hosts on the local Ethernet network to discover them, basically, to discover active hosts. And the last keyword argument that we're going to define, we have proc, we have description, we're gonna define as well epilogue. So we're gonna add some information to the end of the help message when a user provides -h option on the command line. So we're gonna say something funny, super admins watching, although I'm not sure if that's funny for you. Okay, so we have our parser object. Now we will add our arguments, and as I said in the first video, in the first part, to add an argument, whether it's an optional argument or a positional argument, we need to call addArgument method on our parser object, and we're gonna define this target argument. So the target argument will accept IPv4 network range, and based on this network range, we will basically look for active hosts. So we're gonna give it an alternative name, but pay attention, please pay attention to the fact that I'm defining here optional arguments, and this is denoted by the hyphen at the beginning, but we can make with argparse these optional arguments to be required, to be mandatory on the command line. And to do that, we can use required keyword argument, and I'm gonna set it to true. I'm doing this because I want this command line utility to be very explicit, and whenever a user wants to scan a certain network, he will need to prepend the value, the network, with either this short version or the long format version. All right. So we're gonna add as well help message, provide IPv4 net range. I think that should do. Okay, so we're gonna add another argument, and this is gonna be -v for verbose. Again, we're going to give it an alternative name, so the values that a user will pass to these arguments will be stored in these variables. Okay, so again, we're gonna add some message here, turn on verbose mode, and we're gonna set action to store true. And this is something something that we already did in the first video. So when a user provides this -v option, this variable will store true Boolean value. If it's not provided, it will be set to false, basically. So based on that, we can then take action in our main logic. Okay, and we're gonna add the last argument, and this is gonna be -o, and we will allow our users to, or users of this utility to save the output of the program to an external file, to a file. And we're gonna add something new here, something that we didn't cover in the first video, and this is the dest keyword argument. So whenever we want to change the name of the variable where we store the value passed on the command line, we can we can change it using the dest keyword argument. So I'm gonna set it to fout. I think this will be more descriptive than the first name, and as above, we're gonna add some help message. And this is gonna be save program output to a file. Okay, so we're good here. And the last thing that we need to do here is to parse these arguments that are passed on the command line. So we're gonna save these values to args variable, and to parse them, we're gonna call parse args method on our parser object. And our function will return these arguments, so the values that will be passed on the command line. So we can later use it in other functions. Okay, so I'm gonna return args right now. And I'm gonna hide this for the time being so we don't have that much clutter on our screen. And now we're gonna define the core function for our network scanner, and I'm gonna call it netscan. And this will take in one argument, and this is gonna be this IPv4 network range, so I'm gonna call it net. But before we continue with our function definition, we need to import Scapy. And as I said, I have it pre-installed on my machine. So I'm gonna say import Scapy all as Scapy. So we'll refer to each method class prepending this with Scapy name. Okay, so first of all, we need to forge some packets. We need to craft some packets, and the first one is an ARP packet. So I'm gonna say ARP request, and if you're not familiar with this ARP protocol, don't worry, that's not the point of this video. You can always look it up on the internet. So I'm gonna say Scapy ARP. So from Scapy module, we're using ARP class, and this takes in a few arguments, of course, but here we need to provide the target network that we want to send our requests to. So I'm gonna say PDST equals net, and we need to create another packet as well, and this is gonna be our broadcast packet. And again, we're gonna take Scapy class, and this time we're gonna take ether class, and here we're defining the destination MAC address. And this is a special MAC address that all hosts on the local network recognize. So whenever we define it and send a request to this MAC address, it will get through to all active hosts, basically. So I'm gonna say DST equals, and this special MAC address is the following. All right, so we're good here. Now we need to, with Scapy, we need to compose these two packets that we created into one. Okay, so I'm gonna say ARP, let's call it ARP broad request. And to compose combined packets, basically, in Scapy, we can use just /. And I'm gonna say broadcast, this is our lower layer packet. And we're gonna put /ARP request. And there we go. we are our packet ready. We have our packet ready, sorry, and we are ready to send it. And to send packets with Scapy at layer 2, because that's what we're doing in this video, at data link layer, we can use SRP method. And this SRP method, what it does basically, it sends these ARP ping requests, and it will save the results. It will return basically a tuple of two values, and I will show you this in a bit. Okay, so I'm gonna say ans, and this will stand for answered request, and announce for unanswered, and we're gonna say Scapy SRP method, and we're gonna put this arbroad request packet. We're gonna set timeout as well, because we don't want to wait forever for our for the reply, and we're gonna set verbose keyword argument as well to false, because if we didn't, we would basically get some packet emission beginning info when we run our script, and we don't want to do that. We don't want to see it in our network scanner. So now, actually, what we can do here, we can return this so that I can show you the packets or the replies we get when we run this function, so we can understand it better. Okay, so I'm gonna say return ans announce, and once we inspect it, we'll be, oh, it looks like I made a mistake here in the first function, and it's syntax error is watching. Obviously, I didn't put a comma here. Why would I? Okay, now let's try to run this again. It looks like it's working right now. Okay, so we can use our netscan function, and I will provide this network range, and we will save it to resp variable. And this shouldn't take long, so we should have the results in a second. All right, we got this. Let's take a look at that. So we get a tuple of two values as you can see, but that's not the only information we can get. We can loop through each of these values, and I will show you that in a bit. Okay, so for example, if we do something like for item in resp, let's print out an item, and let's see what we get. So we get much more information, and that's what we're interested in, because our network scanner will send this ARP ping to hosts on the local network, and we will grab MAC address and IP address of active hosts basically, and this will be the output of our tool. Okay, so now that we have this output, let's see how we can get specific values here. So as you can see here, we get a couple of values because we got two replies basically for our request. But as you can see here, we have a comma. So this is as well separated into two values. So to access values from the second item here, we need to use indexing on our item as well. So I'm gonna put the 1 here, because this is something that went out from our machine basically, and this is the response that we get back from active host, and that's what we're interested in. So to, for example, print out MAC address of the target machine, the machine that sent back the reply, we can use this dot notation, and we can simply print MAC address that we got back. Okay, so that's what we will do in our netscan function as well, because later on we want to save this output to a file. So we'll create a dictionary object to store this, and we'll return this as well, along with answered and unanswered messages. So I'm gonna create IPs list. So here we will store IPs and MACs for MAC addresses. And now we will loop through answered request. So I'm going to say for element in answered, and I'm going to append each IP address to our list. So I'm going to say IPs append lm, and we are accessing the second value. And first of all, we want to grab the IP address, and now we want to append MAC address. So we're going to say lm1, and it was HWSRC, right? And now that we have it, we can basically save this to our dictionary. And I'm doing this way because I want to save this data later on to a data frame, and pandas, we'll use pandas as well in this while working on this tool, because it provides very convenient ways to save data to a file. Okay, so we have resdict, and we're going to call it IP address, and we're going to assign it to IPs, and we're going to do the same with MAC address, and we're going to do assignment here as well to max. And our function is ready for scanning, for sending these ARP pings. So we're going to return ans, unans, and resdict. Okay, so let's compile this and let's run this here one more time. So I will show you what this dictionary looks like. And now at index 0 we get answered request, and at index 3, basically, because we start indexing at 0, we get our dictionary data, and this is something that we will output to a file later on. So we can actually hide this as well, because we get too much clutter. And now we will prepare a function that will print out results. Okay, so I'm going to call it print results, and this will take in results from our netscan function. And here I'm going to as well define another argument, keyword argument. I'm going to set this to false, because depending on whether a user provides this -v option on the command line, we will then output more information or not. Okay, so I'm going to put a colon here, and we're going to start with our print results definition. So first of all, I'm going to unpack our results. So at index 0 we have our answered request, and at index 1 we have our unanswered. And now we can basically print out this information already. So I'm going to say, let's do it like this, MAC address. And first of all, we're going to print out MAC address. We're going to put 2 tab spaces. That should be good. And we're going to print out IP address header. So this will be our header of our data output. And maybe let's print out some separator as well. So this is generally good. So I'm gonna multiply this dashes by this number, and now we're gonna grab the values that I showed you from our answered request. We could do that from this dictionary as well, but let's practice the Scapy elements, so that we get to know this library a little bit better. Okay, so we're looping through this answer request, and we're gonna print out MAC address, and we're gonna add, let's add space, tab space, and we're gonna concatenate this with another value, with another string, and this is gonna be IP address. Okay, so now we have our output ready, but we wanted our users to provide this -v option. We wanted our program to be more verbose, So whenever this flag is set to true, and this will be derived from this optional argument on our command line, we will output more information. So if we're verbose, if this is true, basically, we're gonna print some message here. But first, let's add a new line, printing. Let's call it printing unanswered summary. We'll have a chance to print out the summary because there is a convenient way in Scapy as well to print summary of the packets. And we're gonna add this separator here as well. And we're gonna loop, but this time through unanswered variable, and we're gonna print summary of each element. Okay, it looks like we have everything we wanted. Let me take a look at that quickly. We don't have any typos. We always do. We'll see in a bit. Okay, so I'm gonna hide this as well. And now we will take a look at the last step. So we'll carry on with the last step, basically, and this is our main function. So I'm gonna say dev main. So we're almost ready, so bear with me. We're gonna say args, and here we're gonna take the values, the return values from our getArgs function. So this will be our values provided on the command line. I'm gonna say getArgs, and we want our results as well. And here we need to provide the target, so our IPv4 network range. So we can access it based on our args variable. As you can see, we can access each value passed to the argument by using this target, verbose, or fout names. So I'm gonna say args target, and I want to grab as well this dictionary structure results, and it was at this index, right? All right, and now we are going to provide logic or build logic for our verbose output. So if a user provides this -v option, so we're going to say args verbose, that's how we can access this variable. We're going to print results. So we're going to use our print results function, and we need to pass the results of netscan function to our print results function, and we're going to say verbose equals true. Otherwise, just print results without unanswered packet summary. Okay, so there we go. We have it. We need to finish the last part, which pertains to this optional -o argument, and this will allow us to save output of the program to a file. And we can add another conditional here, and I'm going to say args fout. So again, if this optional argument is provided on the command line, this action will be taken basically. Because if we don't provide any values, if we don't use this optional argument, the value will be none, and this will not evaluate to true, so this piece of code that we're going to write will not be executed. But before we finish this, let me import OS module, because we want to print out probably the directory where we will save the file. So I'm going to say import OS, and while we are at it, we're going to import pandas as well. That will allow us to save this dictionary to a data frame object and output this to a file. Okay, so I'm gonna first grab current working directory, and we can use this get cwd method from OS module. And next we're gonna create data frame object, and we're gonna pass it our dictionary, and this is, what was the name? Resdict. That's right. And now we're gonna, let's say we're gonna save it to a CSV file. Why not? And we can grab as well the name of the file by using fout attribute. So I'm gonna add another argument here. We don't want the index of this data to be printed out or to be saved. And the last statement that we're gonna add is print statement. So I'm gonna use fstring here, and we're gonna say results have been saved under the following directory. Oops, this long directory, and we're gonna pass in here this cwd variable. All right, so it looks like we have everything. So I'm gonna move on to the next line, and our main function is ready. So I'm gonna minimize this. We're gonna add the last statement that will prevent execution of this script whenever someone or we import one of the function to another file. And this is thanks to this statement, if name equals main, execute main function. Okay, that's it. So it looks like, whoa. All right, I made a mistake here. We have a warning, pandas imported but unused. So I want to import this as PD. I think that's what we used in the main function. Let's take a look quickly. There we go. I use PD here. Okay, so it looks like we have everything we need. So I'm gonna switch to my CLI, to my terminal, sorry. And I'm in my Python scripts directory. Let's confirm this. And we can see that this file has been saved there. Let's take a look. Yeah, that's what we want. And first of all, let's run this. So I need to use sudo because Scapy requires this, and otherwise we wouldn't be able to send this ARP request. So I'm gonna say Python, and first of all, let's take a look at the help information. Obviously, I need to provide the password. And as you can see, we have our tool description, so to speak. We have the name of our program, we have optional arguments, and pay attention to this argument. Although we defined this as optional originally, because we provided these dashes, we set the keyword required argument to true, and it makes this argument obligatory. So without it, our program wouldn't work. We have our description and optional arguments as well here, and the epilogue information. So now we can basically run it. So instead of -h, I'm gonna be explicit. I'm gonna say target, and we're gonna provide our network range. And remember, whatever we passed on the command line, this will be stored as a string. So as you can see, we get a nice output of the active hosts on my local Ethernet network, and this is thanks to this ARP ping request. Okay, so now let's take a look what happens when we provide -v option for verbose. We'll have our terminal cluttered probably. Ooh, it looks like we have an issue. So let's take a look. Attribute error. Okay, let's troubleshoot this. Why not? So we get this assigned verbose for eliminance. If verbose, okay, print results. Obviously, yeah, that's the mistake here. Instead of anons, we need to print out the summary. That's what we want. Okay, that should be fine now. But let's make sure. First of all, I'm gonna clear the screen. Let's see if that works. Okay, so that's all these messages that went unanswered. So that's basically on abstraction layer what happens. Such kind of messages are being sent out in a human readable language. So let's clear this again and use this -O option. Obviously, we need to provide the file name to which we want to save our output. So I'm going to say just data CSV. And let's see if that works. Results have been saved. Okay, and let's list the content of this directory. Let's take a look at data. We have everything we wanted. So that would be it. I hope you liked this video. If you did, please do not forget to hit the subscribe button. Thank you for your time and see you in the next video. Bye bye. Take care.